How old can ice cores be dated with carbon dating? Imagine holding a tiny piece of Earth's ancient history in your hand. That's what scientists do when they analyze ice cores from polar regions. These ice cores are like time capsules, capturing climate clues from thousands of years ago. But how do they figure out exactly how old they are? One key method is carbon dating, which measures the amount of a radioactive form of carbon called carbon-14. Now, ice itself is mostly frozen water, which doesn't contain carbon-14 in a way that can be directly measured for age. Instead, scientists look at organic particles trapped inside the ice. These particles come from plants, animals, or dust that settled onto the ice surface long ago. When these organic materials are analyzed, the amount of carbon-14 they contain can tell us how long ago they were deposited. Carbon-14 has a half-life of about 5,370 years. That means after this time, half of the original carbon-14 has decayed. Because of this, carbon dating is most accurate for samples up to around 40,000 to 50,000 years old. Beyond that, the remaining carbon-14 becomes so minimal that it's hard to measure accurately. In polar regions, scientists extract large samples of ice to find enough organic material for testing. They use highly sensitive equipment called accelerator mass spectrometers to measure tiny amounts of carbon-14. This equipment can detect even minuscule traces of organic carbon, allowing precise dating of the layers. However, dating older ice is tricky because the organic carbon content can be very low. Sometimes the organic particles come from sources outside the ice, which can slightly skew the results. Also, gases trapped in the ice can be of different ages than the ice itself, adding another layer of complexity. Most ice cores from Antarctica, which can go back as far as around 800,000 years, are dated using a mix of methods. These include counting the layers, analyzing isotopic ratios, and measuring other radioactive elements. Carbon dating plays a vital role for the more recent sections of the ice core, up to about 50,000 years. In practice, scientists use specialized equipment designed for ice core analysis. These include large, sensitive detectors that can handle big ice samples and detect tiny organic particles. This combination of advanced technology and multiple dating methods helps researchers piece together Earth's climate history from the polar ice. So, in short, carbon dating can reliably tell us the age of ice cores up to about 40 to 50,000 years old. For older ice, scientists combine multiple techniques to build a full picture of Earth's past climate. This helps us understand how our planet has changed over hundreds of thousands of years.